Hello, welcome to this video tutorial which involves some more brackets. In particular, this particular tutorial will be looking at brackets involved in equations. Now there is a difference between an equation and an expression. An expression involving a bracket could look something along the lines of 3 multiplied by 7x plus 2. That is an expression. We're expressing something with x in it. However, what about an equation? What is an equation? Well, an equation has an equal sign. So I could say, here's an expression. It could be anything, how much money I've got in my pocket, how many marbles are in a bag, various different things. But I could make it equal to something. And that could be anything. That could be another expression or a number or a letter or anything really. But for this example, I'll say it's equal to 48. Now, how do we solve this? Well, some people might choose to solve it using the trial and improvement and sort of say, well, if x was 1, would that work? 7 times 1 plus 2 times by 3, does it equal 48? And sort of try and improve on that. But that is actually time consuming. It takes quite a bit of time, especially when the value of x is not an easy number. It might be 1.2, it might be 3.5, or something, a decimal number, or a fraction, or whatever. So it's not quite as easy sometimes, which means that we need to be able to solve things like this with brackets, or sometimes even without brackets, but being able to do it from first principles, or the building blocks, or whatever you might want to call it. So how are we going to do this? Well, we're not going to look at the basics of how to solve an equation. That's for another tutorial. However, what we will do is take a very small look on how we can help ourselves. And again, this is shown in another tutorial for the basics of equations. Now, usually we use BIDMAS when we're substituting values and things like that. However, for solving equations, trying to find the value of a letter or an unknown quantity, x, y, z, or whatever it might be, we use BIDMAS. Well, in fact, it's a tool. We can use BIDMAS, but going backwards. So when we get to subtraction, addition, multiplication, division, and so on and so forth in that order, we'll try to remove those particular quantities that are subtracting or adding or multiplying and dividing and so on and so forth. We'll try and remove them. So eventually we're going to get x on its own. So at the moment, I can see that we have a 3, a 7, and a 2 that are all kind of mixed up with the x at the moment. They're all involved with x on the left hand side of the equation. So what we'd say is this is the left hand side and this is the right hand side of the equation. So on the left hand side we've got the x, and we need to kind of remove this 3, 7 and 2. However, these are brackets. Brackets come right at the end, so we're not looking to do anything with anything inside the brackets until we've moved everything from the outside, i.e. this 3 on the outside. So if we think about it, we've got subtraction, nope, addition. Well, yeah, we're adding 2, but that's inside the bracket, so that must be part of this b for brackets. Then we're multiplying. Actually, we've got a multiplication inside, this 7 times the x, and the 3 times by the whole of the bracket. So actually this 3 is the first one that we need to try and remove from this left hand side. But how do we move a multiplication of 3? Well, from the other tutorials that I've explained about, we need to do the complete opposite, which is dividing by 3. So what we've essentially are going to do is divide the left hand side by 3 and divide the right hand side by 3. There we go. So what happens when we do that? Well, let's have a look. I'll write this all out again, and in this colour I'm going to do division by 3 on both sides of the equation. Let's just make that equals a tiny bit more readable. Okay, so we're trying to divide by 3. Well, what happens on the left hand side when we divide by 3? Well, the aim was to remove this times by 3. So if I've got 3 and I times it by anything, 7x plus 2 could be any number, doesn't really matter, but there is a quantity here. So if you think of a number and then multiply it by 3 and then divide it by 3, hopefully, if you've done it correctly, you're going to end up back with your same number, i.e. this same bit here or the same bracket. So actually this times by 3 and divide by 3 cancel out to just make 7x plus 2 on the left hand side of the equation. Some people like to think of it as taking this 3 and moving it across the equal sign, but where you move it across the equals, it becomes its kind of opposite, which is divide, which is where we get this from. Totally up to you how you think of it. The former way here with this timesing and dividing here is actually the more correct way. But anyway, we're left with 7x plus 2 on the left. Then we've got the equals, and then what happens on this right? Well, 48 divided by 3 is actually fairly doable, nice and easy. It actually works out to be 16. So here we go. We've moved from up here, this starting bit here, to just having this 7x plus 2. So we've actually removed the 3 from the left-hand side. We don't actually need these brackets anymore. The brackets usually only there to say, well, something else is being done to that whole bracket, like timesing it by 3, or whatever, dividing it by 10, or square rooting it, or whatever. It doesn't really matter, but usually the brackets are only there to signify that there's an order in which something needs to be done. So actually we could remove the brackets. Here we go. That's still exactly the same thing. So what will we do next? Well, we're back to BIDMAS. Start again. We've removed the brackets, so we go back to the start. Have we got any subtraction? No. Have we got any addition? Yes, we have. We've got this plus 2. So we're going to remove that plus 2. How are we going to move it? By either shifting it across like this and making it a negative. So that makes 16 take away 2. Or saying, I will take away 2 from both sides of the equation. Totally up to you how you think about it, but the likelihood is that you need to end up with this. 7x equals 16 take away 2. Well, we know 16 take away 2 is 14, so we can put that there. And then the last step is 14 divided by 7, which makes 2. So actually x equals 2 in this particular case. So that's how we deal with this type of equations in brackets. Now that was actually, believe it or not, one of the easier ones. So the next step, if I can just remove this, is to look at some slightly harder ones. Okay, so let's and the reason why some of these will be a bit harder is because when brackets are involved, along with fractions, here we go, here's a fraction, in an equation, so there's an equation, it can be a bit more tricky. This one's not as tricky as the next one that we'll look at, but it's still very useful to have a look at. And the first step that you need to sort of think about when you've got algebraic fractions and brackets and things like that, very first step is trying to split the fraction. So splitting the fraction, what does that mean? Well, it means that we need to remove this denominator, whatever's the denominator, it might be a number or an expression or a letter or whatever, you need to remove it. How do we move it? By multiplying everything else by this denominator. So, what happens? Well, we've got 4x plus 2 over 2, and that's equal to 3. But what we're going to do is multiply by the denominator on everything. So this side and this side. So I've got 4x plus 2. I'm dividing it by 2, and then I'm timesing it by 2. So divided by 2, timesing by 2 is just completely opposite. So that and that cancel out. And what we end up with is on the left, 4x plus 2 only. So just like that. So we've actually split the fraction up. But what happens on the rest? Well, in this particular case, we've got 3 times 2 on the right hand side, which makes 6. So there we go, we're back to a nice sort of two-step equation that can be solved fairly easily by using our backwards BIDMAS thing. And again, I'm not going to sort of divulge too much into that because that is for another video, the explanations of the backwards BIDMAS and how being able to solve basic two-step linear equations. But what it works out as this 2 comes across as a negative, 6 take away 2 is 4, and then we do x equals 4 over 4, which equals 1. So there we go. The aim in with fractions, with brackets and things like that, is to split that fraction. And I'm not actually going to delete that bit. I'll just delete the example, and we'll look at a slightly harder one. Now, this is going to be slightly different, and the reason why it's harder is because the x is now on the bottom. Now, if you remember, split the fraction, and this is actually can be expanded by saying by multiplying by the denominator. There we go, by multiplying by the denominator. So what is the denominator in this? Well, it's actually 3x take away 1. This whole sort of expression in the bracket is the denominator. So we're going to need to times by 3x take away 1 on both sides. So what will happen? Well, the 3x take away 1 times in by that actually just again cancels with the denominator, and we just get a 6 on the left. So it's nice and easy. You just end up with the numerator on the left hand side. It might be the right hand side if it's a different type of question, but the point is when you times by the denominator, all you're left with is the numerator. But anyway, what's the next step? Well, we've got the equal sign, and on the right hand side we have this 3, but we need to multiply that also by the denominator. So what is 3 times by 3x take away 1? Well, you can see here we're back to being able to expand a single bracket. And how do we do that? Well, various different ways covered in a different tutorial, but hopefully you can follow me where I say 3 times by 3x is 9x, and then 3 times by minus 1 is minus 3. And here we go, back to a single, a two-step linear equation. How do we do that? Move the negative 3 first, and then divide by 9. So we end up with 9 equals 9x. 9 over 9 equals x. So x equals 1. There we go. So that's solving an equation with brackets involved in fractions, with a denominator and things like that. There is actually a harder question, and we'll look at that just now. Oh no, I won't delete the advice. Split the fraction. That should stay there. It should be relevant to most questions involving brackets and fractions. Okay, so here we go. 2x take away 3. This might seem a little bit daunting, this question. Taken from the CyberTutor downloadable documents on the library. Something like this. It's a whole array of different algebraic expressions all formed into an equation. Here we go, we've got 2x take away 3 over 4. That's one expression. Here's another expression, it's just an x. We're adding x to that whole kind of fraction. And then we're making that equal to a whole different algebraic expression involving fractions. And here we go, here's some brackets. You can put your own brackets if you wish to. The reason why there's a bracket there is because this division, or this fraction 9, means that we're dividing that whole lot by 4. So the order of operation should be the brackets bit first. That 2x take away 3. But anyway, it's not as important to keep the brackets there. It just kind of tidies things up a little bit and keeps things a bit more uniform for learning. But anyway, what are we going to do with this? Well, the golden rule: split the fraction by timesing by the denominator. However, this can be fairly difficult, because you might think, well, I've got two fractions here. I've got this kind of first one here and the other one here. So which one do we times by? And the actual answer is both. You times by both. And if you can times by both, you'll completely split every single fraction. It just takes a bit longer. So what we're going to do is times by one of them first. It doesn't really matter. We can start with this one or this one. How about we just start with the left hand one? We've got this 4. 4 is the denominator, so we need to times by 4. But not just on this bit and the other side of the equal sign. There's actually this whole separate term here, this plus x, that needs to be times by 4 as well. So we need to times every single term in the equation in order to keep the equation balanced. So, timesing by 4, what happens? That cancels with that, doesn't it? There's no change in that at all, so what we end up with is 2x take away 3. Let's keep that in a bracket just to tidy it up. What about this x times 4? Well, that makes 4x, so I'll put 4x there. And then we've got an equals, and then we've got this times them by 4. And if you want to, I mean, you can multiply the brackets out if you wish to, but for now I'm just going to write 4 times by 2x plus 4 over 2. That means that 4 is times in by that, which is exactly what we've been aiming to do up here. Okay, so where next? We've split that fraction. It's always good to review your work. We've split that fraction, that works a treat. So the next step is to split this fraction. We've got a times by 2 because the 2 is the denominator. So we'll times by 2 here. Don't forget to times by 2 or times by whatever denominator it is in every single term. So times in by 2 in all of it. So what happens? Well, this first term here, you can multiply the brackets out, expand the brackets if you wish to, but I'm just going to put the 2 on there first. 2 times by 4x is 8x. 2 times by 4 times by that whole thing is just pretty much like this. But in fact, let's go to this next step. Let's multiply this whole bracket out. 2 times by 2x and then 2 times by minus 3. So that makes a 4x take away 6. And then we've got to add an 8x. But what happens here? 2 times 4. Well, that's just 8. Although forget that edge of the bracket there, the closed bracket part. To do 2 times by 4 times by this whole bracket is just the same as saying, well, I've got 8 lots of those brackets. So I can just put 8, 2x plus 4 all over 2. Or the easier way to think about it, if I just go back a couple of steps, is to say, well, I have from up here, I was times it by 2 because that was the denominator. So in other words, that and that cancel out, which just means that I've got 4, 2x plus 4. There's various ways you can do it. There's no kind of set rule to say you have to do it one way or another, but you'll just learn to develop your own technique. So anyway, we need to multiply this brackets out. We could do that first, or we can simplify the left hand side. Really doesn't matter. I always like to start on the left hand side. It's always a good starting point. So I've got a 4x, take away a 6, and then plus an 8x. Well, these x's can be combined. That makes 12x. And then I've got to take away 6. This bracket here can be expanded by multiplying out the 4 with the 2x and the 4. 4 times 2x is 8x. 4 times 4 is 16. So there we go. Now where from here? Well, I'll just take this and give ourselves some more room. There we go, up here. Let's get rid of that. So where from here? Well, we need to collect all of the x's together. How do we do that? Well, choose a side that you want x's on. I always like to choose a side where I've got more x's. So here we go, here's 12x. So I'm going to choose that side to collect my x's. So if I just write x's on the left and then numbers on the right. So how do I get the x's onto the left? Well, I've clearly got an x on the right, or 8 x's on the right. I'm going to move them over. That must mean that they're going to become negative, if that's the way you wish to think of it. 12x, take away 8x, take away 6 equals 16. Now 12x take away 8x is 4x. And then I've got minus 6 equals 16. Well, we said that we're going to have the x's on the left, and we've got that there. But we also said we're going to have the numbers on the right hand side. So that means we need to move the numbers from the left onto the right. So I'm going to move this over. This is a negative, so on the right hand side it will be a positive. 4x equals 16 plus 6. Just switching the sign there. 4x therefore equals 16 plus 6 is 22. So what must x equal? Well, it must be 22 divided by 4. And that has a final answer of 5.5. So 5.5 equals x is the solution for our original equation. Our original equation right from the start. And if you were to put in 5.5 here, here, and here, the whole equation will balance out very nicely. So this was a very complex equation involving expressions of x, brackets, but the really important thing to do is split any fraction first. Split any fraction by timesing by the denominator, and don't forget to multiply that denominator by every single term in the equation, not just on the other side of the equals. That's really important. Okay, that's the end of today's tutorial. So if you wish to have a go at any other practice questions, have a look on the website under the library. Thank you. Laura, so here's a single bracket expansion. Are you happy to give that a go?
Yeah. Would it be 6x plus 5?
No, actually, it's not quite that. Not quite right. Do you want to give that another go?
Oh, was it 3 times 5 as well?
Yeah, 3 times 5 as well.
So it'd be 6x plus 15.
Yeah, perfect. Well done.